Hello everyone, today I'm going to be showing you how to hook up a photoresistor to an LED to make it go on and off depending on the light level. In this case, I'm going to make the LED go on when it becomes dark and go off when it becomes light enough. Similar to how you would have lights lighting up a path in the night that are going on when it's dark. So first, let me explain what a photoresistor is. Basically, it's just a resistor that can measure the light level, and then it's going to take that light level and input it back into your Arduino, and then based on what you code, it's going to be able to give an output to your LED. So let's start by wiring this up. All you'll need is an LED, a photoresistor, a 220 ohm resistor, a 1K resistor. I have 7 jumper wires over here, 2 longer ones to reach further away. Obviously, you'll need an Arduino Uno and a breadboard. Okay, so I'm going to take my breadboard to start off with. I'm going to take my LED, plug it in with my longer side on the left-hand side. That's not very important as long as you know which side is the longer side, because that's the positive side, also known as the anode. I'm going to take my 220 ohm resistor over here. I'm going to plug it into my anode, well, into the same row as my anode, as well as plug it into a bit further away. And then I'm going to take a cable. I'm just going to take the Arduino itself and plug into pin number 13. And then I'm going to plug it into the same row as my resistor, just like that. There we go. Then, lastly, for the LED, I'm going to take another cable. I'm going to plug it into the same row as my cathode, so the shorter side. And then, just like that, you can see that my LED is completely wired up. I'm now going to take these 2 longer cables, and I'm going to plug the first one into my ground over here, which is the third one from the bottom. I'm going to plug that into my negative. And I'm going to take this one, which is going to be the positive coming from my 5 volts over there and going into my positive line over here. Then let's finally put in my photoresistor. Sorry, the cables are sort of in the way now. The photoresistor is going to just go into over here somewhere. I'm just going to put it over here so that you can see it clearly. There we go. I'm going to take my 1K resistor. This can also be a 220 ohm resistor, but I think it's better with the 1K resistor. And I'm going to put that into here. Does not seem to want to go in very nicely. There we go. Just like that. And then this is very important. I'm going to take the same line as my photoresistor itself, the same vertical column, just like that. So in that vertical column you have the photoresistor, your resistor, and this thing, this wire, and that's going to go into the A0 analog pin over here. The analog pins are able to be read by something like a photoresistor, and I'm going to take from my negative side, which is actually, sorry, that's actually the positive side, and I'm going to plug that into my positive line over here. This is important that I actually go over this gap because I have not connected up this side. And then last cable over here, that's going to come from the same line as your resistor on this end, and that's going to go into your negative side over here, just like that. Everything is wired up. I'm going to set it up with my computer by just plugging in the USB cable, and I'll see you just now. Okay, so as you can see on the bottom right of your screen, I've set up the Arduino that I just wired up into my computer using the USB connector cable, and now I've opened the programming Arduino site and I can start coding. The first thing I'm going to do is state my variables, which is the LED, for example, which is into pin number 13, just like that. I can add a space there to make it look a bit nicer. And also, this one is actually very important. I have to say that my light, so the level of light that I have, is equal to 0. This is just saying how much light I have. I can also add another variable saying that my photoresistor is equal to A0, since that is the analog pin I plugged it into, but that is not necessary as long as I don't refer to it later on. So over here I can say pin mode for 13 is an output, just like that. That is important that that is an output, as it is receiving an input to be able to give your output of light. In your void loop, this is your important part of your coding. This is actually what is going to be running. I'm going to say that my light, so that's that light over here, can only be changed by, so cannot be 0, if the analog read of A0 is different. So basically what I'm saying is light is determined by the analog read of A0. I'm going to go to my next line and I'm going to start an if-else statement. If-else statements are very simple and they go something like this. You say if, you open a curly bracket, and then you go over here and you can say else, and you open another curly bracket like that. Whatever I put in this curly bracket, if that is true, it's going to be playing the code that is run over here. But if that is not true, it's going to be doing the code that is over here. So let me first, before I decide that, let me first say what it has to do or what it doesn't have to do. I'm going to say digital write of LED, so pin 13, is high. And then I'm going to say, because that is high on this side, I'm going to say this is low on this side. So as I mentioned earlier, I want my LED to switch on when it is dark outside. So basically, I want this to be high when it is dark. And the only way it's dark is if my light level is less than 450. That is an average light level of like a room. So if it's going to be less than that, then it's going to be switched on. And if it is going to be more than that, it's going to be switched off, just like that. And now I can actually add a delay over here. This delay is very important. What it's basically doing is making this read again. It's letting the analog read again to tell you how much the light level is this time. For now, I'm going to keep this. As 500. And that's important because I firstly don't want to make it lower than 500, because imagine it's halfway like between day and night, so now it keeps changing in light level because there's clouds and stuff. Now your LED is just going to be flashing on, off, on, off, on, off, and you're going to break your LED. So it's important to have a delay, but you don't want to make it too little. So now this should be my coding done. Basically what I'm saying is if it is dark, please switch on the light. If it is not, keep it off. So let's check my coding to make sure everything is right. Cool, everything is right. I'm going to send it to my Arduino itself. You could see the LED flash there. That's not saying that there's light level or anything, that's just the code that came through. And now you can see it's off because it's pretty light in here. If I put my finger over here, you can see that it actually goes on because it's very dark now. You can see that it instantly switches back off the second I make it light enough. You can obviously mess around with these values over here on your coding. So for example, if you wanted to go off quicker, you can make this a higher number, saying 700 for example. If I send that to there, it's going to go off quicker. So as soon as there's even just a bit of shadow, it's going to go off. And I can even make this even higher if I want, where it will basically be off anyway, as soon as I make it dark. But I can also reverse this, so if I say is greater than 1000, then it must go on, something like this. This is obviously, it's now going to stay off, and the only way I think I can actually get it to go on is if I take a high-powered torch and point it directly at that. You'll see that the LED goes on, the LED is off, on, off. So this you can use for example, if your light has to stay, if your room has to stay dark, then you can make it so that it has to stay in a certain light level. And that's it. That's all you need to know for wiring up a photoresistor to an LED to make it go on and off. Thank you very much for watching. I'll see you in the next one.